Hello everyone and welcome to the topic of MDT use cases. In this we are going to discuss about MDT use cases. MDT as minimization of drive testing. So let's discuss about various use cases of MDT. There are various use cases for the operators from the perspective of MDT. So as from the perspective of MDT, the various use cases which are defined like coverage optimization is there, mobility optimization, capacity optimization, then we have parameterization of control channels, quality of service verification is also there. Coverage optimization. It is one of the most important aspects of the network performance and it can directly recognized by the end user. So with the help of MDT, it is possible to detect the signal strength and location of the mobile. And it could be used as a coverage indicator also. However, the main problem is that the signal strength between the mobiles at the same location and the time, they can differ much more than positive and minus of 6 dB. Coverage optimization. Like another problem is that it is unknown if the mobile is inside the bag or some car, which can lead to the signal losses. It lost MDT is used. It is not if we are using the lost MDT type. It is not possible to know if it was a network failure or the mobile failure. So this is basically a problem and it could be solved by collecting many measurement data and it could be merged and then statistically evaluated after that. Another problem is that how to get the location inside the building. It is also suggested to use a GNSS chip as a location provider. There is also a need for good coverage inside big buildings like airport also. This requires indoor measurements, but there is a GNSS chip which is not usable in this. With the help of this drive testing and as scanner as a measurement device, it is possible to collect the coverage measurement in high quality. The problem in this is that it provides only a snapshot of that area where the drive test was executed. Mobility optimization. Another use for optimizing the mobile network is the mobility optimization. And here the main aim is to have handover failure rates which are as small as possible. This handover failure can happen if the mobile and networks do not recognize that a user travels from one cell to another, or then as a consequence of that the user travels from one cell to another, loses the signal from the old cell. Under mobility optimization, another problem could be that load is too high and the handover will take much more time. In most cases, the call would be dropped in this. Next one is capacity optimization. For the network capacity planning, the operator is interested in the downlink and uplink throughput and also the data volume. For example, this is basically to deploy an additional picocell. In 3GPP release 11, the throughput and the volume measurement was also addressed. MDT allows to measure the throughput at the radio access network. Further, in the capacity optimization, a difference to drive test is also that this MDT uses ordinary user traffic and drive test applications with the known traffic characteristics. So by measuring at an application level, the results totally depends on the size of data which is transmitted. On transmissions with small size, the scheduling delay could have an impact on the measured throughput. Whereas with large data blocks, the result is limited by the transmission medium. With the help of this MDT, it is possible to measure the amount of traffic within a cell. The complete location of sending UE is stored together with the measured data volumes. Here the per measurement period, the uplink and the downlink data volume measurement is carried out by the RAM. With the conventional drive test, it is only possible to measure the available throughput at the UE with the test mobile. It is not possible to measure the data volume of a cell in a selected area or detect the areas where users needed more volume. Then parameterization of the control channels. The sub-optional configuration of the common channel parameters like random access, paging and broadcast channels can degrade the network performance. For instance, the UE basically monitors the paging channels which are needed to react to the incoming calls. If now the information cannot be decoded, the UE is not reachable for other calls. MDT defines in If such a failure happens, the location, time, identification and other radio environment are lost. This is also done with the drive test, but the problem is that here only a short time is measured and which may time dependent failures are not detected in this. The operators will find out about the problems with the common channels. The operators only find out about problems with the common channels where they receives the customer complaints. The verification of the in QoS verification. The verification of QoS is an important use case. It is not only the coverage which affects the user experienced quality of service, but also the scheduling principle of packet type connections, which is defined by the operator. The high degree of algorithm flexibility leads to different performances. So in this, it is basically difficult to estimate the QoS from radio measurements like coverage, path loss and average interference. In 3GPP Release 11, the throughput and data volume measurement is introduced, which provide this quality of service verifications. A benefit of MDT throughput measurement is that real user traffic is used and no additional load on the network is produced. Thank you.